In this video, we are going to see about stack data structure. I am Renuka. First, let us see what is data structure. Data structure is the storage that is used to store and organize the data. We may have a question like why we have to store and organize the data. By arranging data on a computer, we can access and update it efficiently. In a linear data structure, elements are arranged one after the another. Unlike linear data structure, non-linear data structure is arranged in a hierarchical manner where the elements will be connected to one or more elements. So the data structure is of linear and non-linear. In linear, we have list, stack and queue, whereas in non-linear, we have trees and graphs. Now in this presentation, we are going to see in detail about stack. Let us see what are all the topics we are going to see in this presentation. First, we will see what is ADT, then why stack is said to be linear data structure, what are all the operations on a stack, then the time complexity, then applications of stack, then we are going to implement that in a program using array. Now first we will see what is ADT. ADT specifies what each operation does, but not how it does it. ADT is a mathematical model which defines various operations that could be performed on a data structure, irrespective of its data type. Stack is considered to be a container in which the insertion and deletion are done from one end, known as top of the stack. We have various operations like insertion, deletion, sorting, searching, etc. So when we see the real-time examples of stack, we have deck of cards, pile of plates. So in this pile of plates, where the last plate kept will be removed first. Whichever inserted at the last will be deleted first. Why stack is called as linear data structure means it follows a particular order in which the operations are performed. The order may be LIFO, last in, first out, or FILO, first in, last out. A stack is sometimes called as push-down stroke. Stack of books is an example of stack. Here we can see many more examples of stack like stack of plates, stack of chairs, stack of rings or discs, stack of coins, stack of plates, can of tennis balls. These everything are the real-time examples of stack. Now let us see the working of stack data structure. The operations will work as follows here. A pointer called as top is used to keep track the top element in the stack. When we are initializing a stack, we will set always the top value as -1, and when we are pushing an element, the top will be incremented. When we are popping the element, the top will be decremented. Before pushing, we should check if the stack is already full, and before popping, we should check whether the stack is empty. Now we will see the operations on a stack. We have four main operations like push, pop, peek or top is empty. In push operation, we will add an element onto a stack. In pop, we will remove an element from a stack, and peek or top will return the top element of the stack. And is empty will return true if the stack is empty, or else it will return as false. In stack terminology, the insertion operation is called as push operation, whereas the removal deletion is called as pop operation. These are all the basic operations in a stack. As I said before, push means storing an element, pop means accessing that element from a stack and removing it. So we have a problem, one problem, we can think what will happen if we try to pop an element of the stack when the stack is already empty. If it is empty already, nothing is there to be popped out from it, right? So this condition is called as stack underflow. It is called as stack underflow. Next, we will see the status of stack. When data is pushed onto a stack, we will check all these conditions like peak is full, is empty. To use a data efficiently, we need to check the status of the stack as well, which is very important criteria. For the same purpose, the following functionality is added to the stack. If it's peak, will get the top element of the stack, and is full will check whether the stack is full, is empty will check whether the stack is empty or not. We have a pointer called as top, which will represent the top of the stack. Now we'll see the push operation in detail. These are all various steps involved in a push operation. The process of inserting a new data element onto a stack is called a push operation. The various steps are: first, we have to check whether the stack is full before pushing an element. If the stack is full, we can't able to push the element, so it will produce an error and it will exit the process. And if the stack is not full, it will increment the top and it will add a new data element onto that stack location, and at last it will return as success. Then if we try to insert the element in a stack and the stack is already full, then that condition is set as overflow condition, which is seen in push operation. In pop operation, we will see underflow condition. In push operation, we will see overflow condition. So when we initialize the stack, we will always set the value of top as -1 to check whether the stack is empty. If the stack is not empty, we'll push an element like top will be top plus 1. It will get top will get incremented. So we can insert many elements. Like it also has some particular value to be inserted. Like the element will be inserted until it reaches maximum size of the stack. We will declare a maximum size. Until that, we can insert any element, whichever element we want to insert. But up to that maximum, above that maximum size, we cannot include any element onto the stack. So we are pushing. This is the pushing operation. It is stored in this picture. After pushing an element, whichever element we have pushed at the top, it is represented as top. And if we want to pop in case, this E only will be removed first. Now we will see pop operation. So accessing an element while removing it from a stack, it is known as pop operation. We have various pop operations like the step one. Here we will see whether the stack is empty or not. If the stack is empty, we cannot pop any element from that. So if it is empty, automatically it will give error and exit. And if it is not empty, it will access the data element at which the top is pointing. Like it will decrement the top value by 1 and it will return as success. So in an array implementation of pop operation, the data element is not actually removed. Instead, the top is decremented to a lower position in the stack to point to the next value. But in linked list implementation, pop will actually remove the data element and it will deallocate the memory space. This is the difference between array implementation of pop and linked list implementation of pop. As I said, we saw the push operation before. The element which is inserted is the top value is arrowing the element E. If you want to pop out, that E will be removed first. So whichever inserted at the last is removed first in this operation, which is stack. Now we are coming into an important point like stack time complexity. So the time complexity of stack operations for array-based implementation of the stack, both push and pop operation will take a constant time that is big O of 1. We will see the important reason like why both push operation and the pop operation has big O of 1 is that see the time complexity of the push operation and the pop operation will stay big O of 1 because the insertion and the deletion of the data items will happen only at one end of the stack. Both the inserting, if you want to insert an element or if you want to delete an element, both will occur at only one end of the stack. So it is a single step process, isn't it? So it has a time complexity of big O of 1. Now we will see here what are all the applications of stack. Stack has many applications like balancing of symbols. We can use in infix to postfix or prefix conversion, redo undo features at many places like editors, Photoshop. So in editors, the undo redo function can be performed efficiently by stack. Forward backward features in web browsers used in many algorithms like Tower of Hanoi, tree travelers. The stack can be useful in situations where backtracking is necessary, such as n-queens problem, etc. Then string reversal, function calls and recursion, program execution. In programming, the stack can be used to reverse the element of an array or string. These are all various applications of stack. Now let us see the implementation of stack data structure. Stack can be implemented in two ways. One is a linked list, another one is using array. In this presentation, we are going to see the implementation of stack using array. So what does mean by array is that array is a collection of memory elements in which the data is stored sequentially, which means in a continuous manner. So first of all, in a program, we include a header file, include stdio.h. Then we are fixing the maximum size as 8. The stack maximum size is 8 and 8 elements we can able to include in that. And as usual, the top value is considered as -1. We are writing the code for checking is empty, peak condition, full condition. When the stack will be empty is that when the top value is equal to -1, the stack will be empty, and the peak value is that when the stack has a the topmost value is set as the peak value. Like in stack of 8 elements, the top value inserted as 15 means that is said to be the peak value. And how we can able to check whether the stack is full or not is by considering that top is equal to maximum size. When the top attains the maximum size, we cannot do any operations in it. Like if the stack size is 8, above that we cannot do anything. That is the maximum size of that particular stack. Now we will see the push operation implementation in a program. The stack is said to be full when the top value is equal to n-1. See the top, if the stack is full, it will say it has error like the stack was already filled up to the top. If it is not full, we can able to increment the top value. When we push an element, we can increment the top value as top is equal to top plus 1. Now we will see the pop implementation in a program. Before popping, we should check whether the stack is empty. So if the stack is empty, we cannot pop any more elements. Like if the top is equal to -1, it is an empty stack. So if it is an empty stack, we will print it as error stack is empty, so on. If it is not empty, we can uh, remove an element from the stack, like the top value will be decremented by 1. Next, we will see we are coming to the main function. In this, we can consider like we are going to push 6 elements onto a stack, like push an element 3, 5, 9, 1, 12, 50. So actually, whichever element pushed at last will be popped out first, which we know already. Now we are going to print the element which is going to be at the top. So see, the element which is pushed at the last, that is 15, push 15 number. So this is going to be the topmost value as we see here. So the element at the top of the stack will be 15 obviously. And when we are going to pop an element, like if it is in this order 15, 12, 1, 9, 5, 3, and we are deciding to pop an element, like the topmost element will be popped first as we saw before, so 15 will be removed. Automatically the top value will become as 12, so that we will get the element at the top of the stack as 12. First we'll get 15. After popping one element, we will get the top value of the stack as 12, and the program will be executed and it will exit. Now here we can see one more task, like we are having the same program. So we are just going to comment this line, like printf statement, the top value we're going to comment, and we are going to do a task like we are going to pop out every element in the stack. So how much means till the stack becomes empty, we are going to pop one element. So we are going to see the result what will be. See, these are the elements which we have pushed, and now we are going to pop out every elements. 15, 12, 1, 9, 5, 3 has been popped out. The element which is inserted at the last has been popped out first, last in, first out. Or the first element, like 3 which is inserted at the first will be removed at the last. This is a simple stack program implementation. And thank you everybody.